Hello everybody. The problem that I had to do for this thing here was 6.39. There's a question about some ropes and some force and some tension and stuff. So I'm going to get started here. The first step I did was to basically redraw the picture that is on the screen when you're getting asked the question. Basically, you got this really heavy beam and it's being held by two ropes, and one rope is at a 20-degree angle from the vertical, and the other is a 30-degree angle from the vertical, as you can see here. And the beam there, it's 1,300 kilograms. The next step I did was just draw basically a free body diagram of what I thought it would be. I'm not really very good at this, so I'm sure it's wrong, but that's okay. I tried anyways. So you have the force of gravity pulling down on the weight. That's the FG there going down. The two tensions are offsetting that, going off in each direction. Nothing is moving here, so basically these should all cancel themselves out. They should equal out to 0 at that dot there. It kind of looks like a flux capacitor. If you don't know what that is, then you're too young and you need to get off my lawn. Alright, so the next step is when all the equations and all that jazz come in. So I labeled basically what I knew and kind of calculated the easy stuff. So we already talked about the net force being 0. I went ahead and calculated the force of gravity, since it gives you the mass, which is 1,300 kilograms, and then you know that the gravity is 9.8 meters per second squared for the acceleration of gravity, or whatever, the g, you know what I mean. So I got that. And the force being pulled down, pulling down the weight with the ropes not being involved there, it's 12,740 newtons. So that's that, yeah. Alright, so step 3 is when I started making some equations here. So the two tension forces that are opposing or basically holding the weight, then you add that up with the gravity, and it's going to come out to 0 since there's a net force of 0. So I set the gravity force, which is the 12,740 newtons, to tension 1 cosine of 20 degrees, which cosine is the ratio between the adjacent side of a right triangle and the hypotenuse. I did the same thing with the 30-degree angle and tension 2. Set those two equal to each other since they offset. So that's step 3 there. Step 4 is basically I solved for one of the t's, and in doing so I'm going to basically do a system of equations using substitution. It's the only way I really knew how to do it, and fortunate for me it worked out. So this time I went with the ratio of the opposite and hypotenuse sides of the right triangle, and I set those two equal to each other, since they would have to be essentially to oppose the weight. And solving for T1, I get the T2 times the sine of 30 degrees over the sine of 20 degrees. Then I did some other crazy stuff here. Basically I substituted that in to the initial equation up in step 3, and once I set that up, I factored out the T2 variable since it was a part of both terms. I did this in order to solve for the T2 variable, and after doing a bunch of crazy math and all this kind of jazz, what it came out to was 5,688 newtons. And, you know, I'll be darned, I put that in and it worked. Said I didn't round right, but I don't care, it always says that. So essentially that is T2. So now that I've done that, I can go back to the original equation there in step 3, and I have a value now for T2. So what I did then was, alright, yeah, so I put that in and I got 8,315. Those are both newtons. I didn't write units because I'm lazy. But since I got here, I'm going to go ahead and do it. Just in case. So yeah, this is, those are newtons. And it was newtons on the other one too. Yeah, and I put those into the mastering physics thing, and it said it was right, and I was actually quite shocked. That's the end of the video. If you have any questions, ask the instructors, because I really don't know what I'm doing. There you go. Go Lightning.